Okay, hello and good day to our lecturer, Dr. Lee Woon Kyo. Okay, my name is Muhammad Najmi Afiq bin Abdul Kadir, and I'm from Group 7. And then I present for my friend, with my friend Muhammad Yazid and then Muhammad Amirul Hazid. Okay, I will make an introduction about our project, uh, about this subject, computer programming. Okay, we use C++ to make the coding to do the project. So C++ is an object-oriented language that provides a clear structure to programs and allows for code reuse, lowering development costs. Okay, C++ is a programming language that may be used to construct applications that operate on a wide range of platforms. In programming class, this type of software was utilized. As a result, the goal is to write machine code using everything have learned so far. Okay, to complete the task, the group must create 3 machine codes, which is lathes, milling, and drilling machines. As a result, a group member needs to comprehend traditional machines and mega metal company procedure before proposing a 3-part design that can be completed by single machines using lathe, milling, and drilling machine until the end product is complete on time. Okay. Beside that, okay, the group members need to show all the process and parameters in detail as well as the necessary calculation to machine raw material. Okay, total part machining time, total energy consumptions, total operation cost by product or solid waste output in kilogram, and anticipated productivity per 8 hours of work must be included in each program analysis for milling, drilling, and and then uh, lathe machine. Okay, the group member also must provide typical machine specification and limitations such as the maximum quantity of allowable material dimension and specific procedure or instructions to follow until a part design is complete. Okay, the problem statement. We as a group members must to find a total energy consumption, total operation cost by product or solid waste creation, and predicted daily productivity are all challenging to predict. Okay, the objective is a group member must assist mega metal company in improving their production, training, and developing three program to guide operators in performing conventional machining for selected mill parts in lathe, milling, and drilling machine using one program for one machine type with one part design and then 2 theory. Okay, the lead machine introduction. Okay, a lead machine is a machine tool that uses a tool which passes across the workpiece and can be driven deep into it to remove unwanted material from spinning workpiece in the form of chips. Okay, in general, the feed movement of the tool is a lead machining form, and its principal motion is the rotation movement of a workpiece with whether it is made of wood, steel, aluminum, or stainless steel. Okay. Okay, for lathe machine have a 8 part. The first one is a headstock. Headstock is on the left end of the bed. That is headstock. The headstock primary role is to transmit power to the various sections of the lathe. Okay, the second part is chuck. A chuck is to hold a workpiece, especially one that is short in length but large in diameter or has an uneven shape. Okay, and then the third part is a tool post. Tool post is used to hold various cutting tools holder. And then the next is a component rest. Component rest in its various settings, it support the tool post and cutting tools. And then the next is a bed. The bed is of the lathe machine serve as the foundation for all of the lathe other components. The bed is supported by large box section columns constructed of cast iron or nickel cast iron alloy. And then the next is a lead screw. The lead screw is used mostly in the case when the threading operation is to be performed on a lathe. And then the next part is carriage. Carriage is during operation. The carriage primary duty is to support, guide, and feed the tool against the work. And then lastly is a feed shaft, used mostly in the case when the threading operation is to be performed on a lathe. Okay, that's it from me, and then I will pass to my friend Muhammad Amirul Haziq bin Mazuri. Thank you.
Assalamualaikum and very good morning. My name is Muhammad Amir Haziq bin Mazuri and my matrix number is CD 2047. So my part of the group I'll be explaining a few of the slides. So first of all I'll be explaining about the specifications of lathe machine. So these are the photo of lathe machine. So there's 9 parts that we're explaining. So first is headstock, shaft, and then two pulls, and then compound rest, tail stock, bed, lead screw, carriage, and feed shaft. So these are the parts name and their functions of the lathe machine. So the first is haystock. So haystock is on the left end of the bed, and there is a headstock. The headstock is the primary role is transmit power to the various section of the lathe. And then the second one is chuck. Chuck is to hold a workpiece, especially on that is short in length but large in diameter or has an uneven shape. So the third one is tool post. So tool post is used to hold various cutting tool holders. And then the fourth part is the component rest, which is in a various settings. It supports the tool post and cutting tool. The fifth is the tailstock. So the functions of the tailstock is to support the other end of the work when being machined. To use a tool to conduct operations such as drilling, reaming, tapping, and other similar tasks. So the sixth part is bed. So the bed is the bed of the lathe machine that serves as the foundation for all of the lathe other components. Sorry. And then the seventh part is the lead screw. So it is mostly used in the case where the trading operation is to be performed on a lathe. And then the eighth part is carriage. So during operation, this function is the carriage primary duty is to support, guide, and feed the doctor against the work. And the last part is feed shaft. So feed shaft is used mostly in the case when the trading operation is to be performed on a lathe. So next up is I'll be explaining the types of operational process that will be used. So there are 3 operational processes. So the first one is the facing operation, which is a procedure which the end of the workpiece is machined by a tool to the workpiece rotation axis. So this facing is also the process of removing material from a workpiece and or shoulder with a specific tool to produce a flat surface perpendicular to the workpiece rotational axis. When facing on a lathe, the machinist cuts a flat surface perpendicular to the rotating axis of the workpiece with a facing tool. So this face tool is then fit across the axis perpendicularly. So the next process I'll be explaining is the turning operation. Turning operation is a method of removing metal from a revolving cylindrical workpiece outside the meter. This turning is also used to reduce the diameter of a workpiece, usually to cut a specific size and to give the metal a smooth surface. This workpiece is frequently twisted in such a way that neighboring pieces have various diameters. In any case, the turning process needs the use of a turning machine or lathe, as well as the workpiece, feature, and cutting tool. The last part of the process is the finishing process. So finishing process is will be produces a clean surface finish and accurately sizes the workpiece. The type of surface finish generated can be influenced by factors such as the condition of the cutting tool bed, the stiffness of the machine and workpiece, and the lathe speed and feed rate. Furthermore, when the part has been created and secondary procedures have been completed, finishing operation takes place at the end of the production process. Finishing is the last phase in the manufacturing process, and it is used to give anesthetic as well as environmental protection. So this finishing is the last phase in the manufacturing process, and it is used to give anesthetic as well as environmental protection. So these are the types of material that we have been used. So first is the wood, second is the steel, and third is the aluminium, and lastly is the stainless steel. Uh, so this part I'll be explaining about the energy consumption. So when energy is consumed in a machine tool, it's an important step to reduce energy consumption. The majority of the energy consumed is attributable to supporting processes rather than material removal, deformation, or joining. It would be good to create an energy flow map to better understand the energy flow and consumption of machine tools. Opportunities for improvement as well as energy-related elements can be found using this map. Following the creation of map models can be created to help estimate energy use and enable for machine tool optimization and more sustainable design.
Assalamualaikum warahmatullahi wabarakatuh, and a very good morning to everyone. So my name is Muhammad Yazid bin Zainal. My matrix number is CD 2099. So my part is I will explain about pseudocode, flowchart, and our result. So we have two types of pseudocode, which is one is for database and one is for the production. So for the database, we start. First we start, after that, and after start we will display all data. After that, choose database, from user to choose database. If case 2, from user for input 2. If case 3, from user for input 3. And if case 4, from user for input 4. After that, break to display all input, and lastly it will end. So for the production, we will start. After that, from user, select the material. After select the material, you need to choose between it is wood, steel, aluminium, or stainless steel. And then choose the RPM, which is 200, 400, 600, or 800. After that, input the diameter for the cutting material. If the RPM is 200, uh, they will start do the they will start to run the machine. Same goes to 400 or 600 or 800, and then display the energy consumption break, and it will end. Okay, so this is the flowchart from the we construct from the pseudocode. For the left hand side flowchart, there is a database flowchart, which is from start we will display the data and input the data. Case 1, case 2, case 3, and case 4. Which is case is the material. It is a wood, steel, aluminium, and stainless steel. And after input the material or case, we need to input 1, or input 2, input 3, input 4, which is input 1, input 2, input 3, and input 4. Uh, it is the 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 RPM, the diameter, or the process that we need to choose. After that, break, and then it will display the output and end. At the right hand side flowchart, there is a production flowchart, which is production is referred to input 1, input 2, input 3, and input 4. Which is from start we need to choose the material, and then select the RPM, whether 200, 400, 600, or 800 RPM, and then select diameter. After which is select diameter, you can put any number, for example 2 millimeter, 4 millimeter, the diameter that we need to cut from the material. And then we need to choose the process. which is facing, turning, and finishing. After choose the process, it will display the time and the energy consumption. Okay, so this is the result for the from the coding. The process is same, uh, but there's different at the material, which is for this is for wood and another one is for steel. For RPM, the RPM for the machine is 200, same with the steel. The diameter for cut the wood and steel also same, which is 4 millimeter. The difference is at the time and energy consumption, which is the time process for wood is only takes 1 minute, while for steel it takes 4 minutes. For energy consumption, the wood takes 2 watt, while an energy consumption for steel equal to 8 watt. Also for aluminium and stainless steel, uh, the process still the same, but the difference is at the time process and energy consumption, which is for aluminium it takes 2 minutes for the time process and 4 watt for the energy consumption, while stainless steel it takes 4 minutes for the time process and 8 watt for energy consumption.
So I'll be conclude for the end of this slide. So what is our conclusion is that the objectives of our project are all have been achieved, and we get to learn about the coding program. And this, from this project, we're able to understand about the function in coding program. And then by using the software, which is the DevC++, it's well easy to use and able to solve any problem that involve with the system. So these programs, C++ programming, can be used in industries. Since the industries are all in 4.0, we'll be mostly using machines and programs. So then we develop, so in this case, we develop a C program for the handbook for the lead machine. After that, various type of problem related to this C++ software that required the same method and techniques was able to be solved. So finally, this project will help the student to improve their understanding in programming and taught student to create a flowchart that able to understand the system very well. So that's all for me. Thank you.